the question that made the universe feel unstable. It began with a question so simple it sounded harmless. What happens if you just keep asking why? Not how fast, not how big, but why anything moves at all. To understand why this question still matters today, we need to return to a time when the universe felt predictable. For centuries, motion seemed obvious. Push something, it moves. Stop pushing, it stops. The world behaved the way our instincts said it should. And for everyday life, that explanation worked well enough. But beneath that comfort was a quiet assumption that motion needed a constant cause, that the universe preferred stillness, and that nothing happened without a continuous reason. This belief shaped how people built machines, predicted planets, and understood their place in nature. It became the invisible foundation of science itself. Even today, we design systems assuming stability, balance, and rest. We expect the universe to behave politely, to slow down, to settle, to make sense. But long ago, someone noticed a crack in that logic, a tiny inconsistency that refused to disappear. The first hint appeared when people watched objects slide, roll, and fall. A stone on ice traveled farther than one on dirt. A wheel spun longer on a smooth road. These were small details, easy to ignore, but together they suggested something unsettling. Maybe objects were not trying to stop. Maybe they were being forced to stop. Maybe rest was not the natural state after all. That idea changed everything. Because if motion didn't need a reason to continue, then the universe was not quietly winding down. It was already moving, endlessly, unless something interfered. Space itself became less like a stage and more like a condition. Motion stopped being a behavior and became a rule. This was the first crack in a comforting worldview. The realization that the universe might not prefer stillness, that stability was not guaranteed, and that beneath the calm surface of everyday life, reality was already in motion, whether we noticed it or not. At first, this new idea felt almost philosophical, a clever thought experiment, not a threat to reality. After all, in the real world, things still slowed down. Arrows fell, wheels stopped spinning. Nothing seemed to move forever. So the old intuition survived, reinforced by daily experience. But beneath that comfort, the contradiction kept growing. The problem was friction, air resistance, rough surfaces, invisible forces that quietly interfere with motion. Once those influences were removed, something strange happened. Objects did not seek rest. They kept going. The universe, it seemed, did not demand effort to maintain motion. Effort was only required to change it. This reversal was subtle, but dangerous, because it meant that motion was not something added to matter. It was already there. Stillness was the exception, not the rule. And if that was true, then centuries of explanations have been built on a misunderstanding. Early thinkers struggled with this implication. Accepting it meant abandoning common sense. It meant trusting logic over intuition. And it meant admitting that the universe did not care how humans expected it to behave. Motion followed rules, not feelings. As this idea spread, it collided with another assumption, that speed was absolute, that movement could be measured the same way by everyone, everywhere. It seemed obvious. If something moved fast, it moved fast for all observers. But the new understanding of motion made that certainty fragile. Because if motion was relative, then speed depended on who was watching. This was the quiet beginning of a deeper conflict, a realization that motion could not be fully understood in isolation, that every movement was measured against something else, and that there was no universal reference point standing still in the background. The universe had lost its anchor. There was no fixed center, no absolute rest, only relationships between moving things. And once that door opened, it could not be closed. Because if motion was relative, then time and space themselves might not be as stable as they appeared. What began as a correction to intuition was becoming a threat to certainty. The rules that governed everyday motion were pointing towards something far bigger, something that would challenge not just how objects move, but how reality itself is structured. This is where the tension deepened. Because once motion lost its anchor, everything connected to it became unstable. Distance, duration, even simultaneity. Ideas that once felt universal suddenly depended on perspective. Two observers could watch the same event and disagree about what happened first, not because one was wrong, but because motion had changed the rules. For centuries, space and time were treated as separate and absolute. Space was the stage. Time was the clock. They ticked forward the same way for everyone. Motion simply played out within them. But now, motion was no longer obedient. It began to reshape the stage itself. The conflict became unavoidable when scientists tried to measure light. No matter how fast the observer moved, light behaved the same way. Its speed refused to change. This made no sense. According to old logic, speed should add together. Chase a beam of light, and it should appear slower. But it never did. Light ignored motion entirely. This contradiction tore through physics. Either measurements were wrong, or the foundations of reality were. And the more experiments were repeated, the clearer it became. Light was not the problem. Assumptions were. If the speed of light was constant, then space and time had to bend. Distances had to shrink. Clocks had to slow. Events that seemed simultaneous for one observer would separate for another. Motion was no longer happening inside space and time. It was sculpting them. This was not an abstract idea. It produced real consequences. Fast-moving clocks ticked differently. Particles lived longer when accelerated. Precision instruments disagreed depending on motion. Reality itself confirmed the theory. Again and again, the universe revealed a cruel truth. Common sense was built for survival, not accuracy. Our instincts evolved in a slow, friction-filled world. They were never meant to grasp a universe where motion is fundamental and rest is an illusion. By this point, the question that began it all had grown into a crisis. What does it mean to move? And if motion reshapes space and time, then what does it mean to exist within a universe that never truly stands still? The climax of this story is not a formula or an equation. It is a realization. Motion is not something that happens in the universe. Motion is something the universe is built from. Once that idea settled in, everything else followed naturally. There was no preferred state of rest, no invisible backdrop holding reality still. Every object carried its own perspective. Every measurement depended on motion. The universe was not a calm machine slowly running down. It was a dynamic system, constantly in flux. This changed how we understood energy, mass, and gravity. It reshaped how stars lived and died. It explained why the universe could expand without flying apart. And it revealed why stability, when it appears, is something earned, not guaranteed. What began as a simple question about motion ended by dismantling certainty itself. Space and time stopped being rigid containers. They became flexible, responsive, and deeply connected to everything moving within them. The universe was no longer passive. It was active, relational, and alive with motion at every scale. Today, this insight quietly powers our world. It corrects satellite clocks. It guides spacecraft across vast distances. It shapes our understanding of black holes and the birth of the cosmos. Most people never notice it, but it is always there, adjusting reality in the background. And perhaps the most unsettling part is this. Nothing is truly at rest. Not the ground beneath you, not the air around you, not even time itself. Motion is not the exception. It is a default state of existence. Subscribe to join the journey.